Hi, I'm Yashil Ramesh, and this is my Unit 7 Simple Harmonic Motion test corrections. So the first part that I'm going to correct is my FRQ, and the reason that I got it wrong is because I left it blank. Or sorry, not because I left it blank, but because I said the velocity would be a smaller velocity, which is correct. However, I did not mention the larger change in momentum. That's because when the dart will bounce off the block, it has a larger change in momentum because it has a greater impulse, or sorry, the same impulse. Yeah. And so since the block has a greater change in momentum, it has a larger speed after the collision in the original case. And here are my notes to support that. The next question I got wrong was question 1 of the multiple choice. And the reason that I got this question wrong is because I didn't add the masses of the cart and the block. So since it is 2 kilograms of a 2 kilogram cart plus a 1 kilogram block, the equation would be 2 plus 1 times 0.8 squared, which is equal to the kinetic energy, which will also be equal to the potential energy of the system. So this is the maximum kinetic energy, and that would be equal to potential energy. And this solved out would be equal to 96 joules, which I had incorrectly stated that it would be equal to 64 joules, and that is because I did not add the masses of the cart and the block. These are the notes to support that. This is question 2. So question 2 I got wrong because I did not know that the formula for the period equation only works for angles that are less than 15 or around 15. And so that makes this answer correct. This answer, that I selected A, make sure the string length is not too long, is incorrect because even though the string length would be longer, that would not change the period for oscillations with the same string length. And yeah, here are some related notes. Question 3, I got wrong because I assumed the magnitude of change would be equal to the change in kinetic energy, which is not true because the magnitude of change in the potential energy from its maximum potential energy to zero potential energy is just the magnitude of the potential energy, which can be used by determining the maximum kinetic energy for the system, which is calculated through 1/2 mv squared. And here, if I measured the kinetic energy at 2 seconds, that would be at its maximum kinetic energy, because you can see here it reaches a maximum. There's some notes. Question 4, I got wrong because I did not use the correct formula. The formula that I should have used would be the one right here, right here. So x equals 5 cosine 16 pi theta, t. And so this was a miscalculation on my part, and if you plug in all the values for this question, you would get 1 over 96 seconds, which is the correct answer. Or 1 over 16 seconds, which is the correct answer. The next question I got wrong was question number 5, which I got wrong because I used the incorrect formula for frequency. So frequency is just 1 over the period, but I had guessed incorrectly. So if you calculate the period here, you can do that through the p equals 2 pi square root length over gravity. So if you use that and you put all of this to the negative first power, you will get radical 5 divided by 2 pi hertz, which is the correct answer for the frequency. These are more related notes. The next question, I got wrong was question number 6. And I got this question wrong because I did not select the period of oscillation for the system would be nearly 5.7 seconds, which can be told through the period of oscillation formula for a spring, which is T S is equal to 2 pi square root mass over the spring constant. And so the period of oscillation is inversely proportional to the square root of the potential spring constant, because if I increase the square root of the spring constant, the period of oscillation will go down. So if the spring factor is increased by a factor of 2, then the period of system should decrease by a factor of square root 2, and that means that it would be 5.7 seconds. Using this graph right here, that would be 5.7 seconds in the second experiment. So that's my test corrections for simple harmonic motion. Oh, and here's some related notes for that last question. Thank you.